Shall we start?
Yeah.
Is everyone
Yes.
back? Okay, Kantesh is there. Ramni, Jayashri, Venu is back.
Yeah.
Okay. Jayashri, are you there?
Yeah, hi, ma'am. Yes, I'm there.
Okay, let's start. Okay, so now this is a very important chapter, variability. Okay, so basically, so far we have studied measures of central tendency, right? So which tells us how to find out a typical value of a distribution. So let's say for this distribution, we said, oh, sorry, we said that this is the mean or mode or median. Okay. Now variability tells us how our data is varied. Say for example, if I take two distributions, one being like this, okay, another one is like this, okay. Both have similar mean, median and mode, right? But the graph, the distribution does not look same, right? Why is it so? Yes, anyone? What's the difference between this red and the green and the blue distribution?
The difference, the graphic data points are different.
Right, data points are different. Means like, no, interpretation wise,
The
like what is
shape of
the?
the graph is also like
Sorry.
it's parabolic.
Hello.
Yeah, can you hear me?
Yeah, now yes.
Green is kind of similar to equal distribution.
Sorry, green is kind of.
Equal distribution.
What is equal distribution?
I mean, the
No, that
frequency.
is parabolic actually.
No, see, both are normal only.
Okay.
The difference is the data for when both have similar mean, median, and mode. The difference is
Okay.
the data is close to the center point in green one, while the red one data is far off from the center points. Okay, means the data is far spreaded, right? So in this chapter we are going to study how can I calculate this spread, okay, which we also call variability. That is how my data is varying, how much is the variation in my data. Clear? Okay, now let's take an example here. Now the question here is, should you get an social networking account? Okay, so a person X wanted to take a social networking account, but he decided that he will only take social networking account if the people with social networking account have a higher salary as compared to the general population. Okay, so what it did was he created a histogram of 1,000 people who have a social networking account, and this was the distribution. To compare it with the general population, it took one more sample of size 1,000, but it was for general population. That is, they might or might not have a social networking account. It's just random population, right? And this was their distribution. Now, the first question is, how can you relate the mean of first with the mean of second, the mode of first with the mode of second, and the median of first with the median of second? And these are your options: less than, greater than, or equal to, that you can fill in this square boxes. So quickly think and give me the answers. Okay, let's discuss it now. Venu has given an answer. Okay. Okay, let's discuss. Where will the mean of first one lie? Hello?
Yeah, between it is near 320 or something like
No, mean will be the mean of the salaries, not the frequencies.
that. 42, it is 50,000.
Right, it will be somewhere in the middle only, right?
60,000.
40
Same.
to 60.
How about here?
60,000.
Same.
Here it's same. Mean is same.
So mean should be approximately equal.
Mhm.
Okay. How about the mode?
Mode
Okay, what is the mode of first one?
330.
No, 330 is the frequency.
Sorry.
The value
It's
is 40 to
50,000.
40 to 50,000.
40 to 50.
How much is here?
Same.
It's
Same. So
same.
mode is also same.
Okay.
Now how about median?
Median will also be same.
Right. So what is the median? Median is the middle value, right?
Mhm.
So if I have 1000 data points, middle value will be somewhere close to 500th point,
Mhm.
right? So let's see how to find out the median in this case. If I have to find out the 500th point. So 33 points are in this bar, right?
Mhm.
155 points are in this bar.
Mhm.
Okay. 330 points are in this bar.
Mhm.
So if we add 33 plus 155 is 188, right?
188.
So 500 will be in this bar only.
Yes.
Getting it, Venu?
That's same actually.
Yeah, 518.
Yes.
So it will be somewhere there.
Yes, it will be in between this bar. Similarly here also, it will be in this bar only.
Mm.
Okay. So median is also similar,
Mm.
Correct.
but still the distribution does not look like the same.
Mm.
What's the difference?
The second one is much spreaded.
The second one is much spreaded, exactly. Well, the first one is consistent, means you have most of the data is from 20,000 to 80,000 only, but it is pretty much spread. Okay.
Mm.
Now the question is, should you get a social networking account or not? Should you get a social networking account or
Yes.
not?
Yes.
Okay, why yes?
Let's although mean mode and median is same with
In both the cases, right? Then why should I have it?
because it is less distributed, or
Right. So basically the reason is that in this case most of the data points are in this region only.
right,
Yes.
Most of them, right? But here it is a bit spreaded. So I have a higher probability to be in this middle region as compared to this. Because what I have done is if I push this graph from both the sides, I might get this. Right? So means in this case I have a higher probability of being in the middle region as compared to this one. So that's why I should have a social networking account. Okay, now answer this one. What is the difference between these two distributions? These are your 5 options. Think and answer. Put your answer in the chat box quickly.
so how to show the difference?
Sorry.
What
Just
the differences between these two distributions?
right. So what options are correct? These are the 5 options you have.
Okay.
Just mark the options 1 to 5 years. Okay. I think you got mostly correct. The salaries of people with social networking account are more consistent. This is true. Kantesh, you did this one wrong. This is more consistent, the first one, because they are close to each other. But this one is not that much consistent. So first one is correct, that the salaries of people with social networking accounts are more consistent. Now it makes second one of course wrong. Okay. People with higher salary don't have a social networking account. Since this is a general population, I don't know whether they have or don't have a social networking account. So I cannot answer this. Okay. Same goes for 4 also. The distribution of salaries of the general public sample is more spread out. That's true. So 1 and 5 are correct. Okay. Great. So now let's see the first method of measuring this spread. As I discussed earlier, I want to find out the spread. So the easiest method is called calculating the range of a distribution. And range is nothing but the maximum value minus the minimum value is the range. Okay. Now for this distribution, maximum is 78,600 while the minimum is 21,180. Okay. Find out the range and give me the answer very quickly.
It's 57,420. 57420.
Let me just check. 5778. It should be 56420.
Okay.
No, let me just check. Let me just check.
No, it's 5742.
Right, 57420. Yes, yes, yes. Sorry. Okay. Now this one also. The maximum is 116020 and the minimum is only 7350. This is minimum and this is maximum. Find the range in this case also.
Minimum is 735.
Minimum is
Right?
7350.
173.
No,
It's
only
only 7.
7350, yes. Is the dollar sign before that.
It's 108670.
108670.
108670. Okay. Kantesh got this?
Yes.
Okay. So now you can see here that the spread of this second one is pretty high by seeing the range. Right? But range has some negative issues also. That is, okay, answer me this, then we'll discuss that. Range changes when we add a new data to the data set, always, sometimes, or never.
Always.
Always.
Range changes when we add a new data to, think and answer in the chat box.
Sometimes. Yeah.
Think and answer in the chat box, please. Okay, we know what's the answer?
It's sometimes.
Okay, what
when
are
the
the
data
some?
is extreme.
Exactly, when we add a extreme value to the data. Okay, but the problem here is if we add some extreme value, the range becomes very high. Let's say, suppose if I add, let me just show. Okay, suppose if I add a salary of, let's say, $1 million here, right? So of course the range will become very high, $1 million minus this one. Okay, so the issue with range is, since it is taking only two values, that is the maxima and minima, to calculate the range, okay, it is very much sensitive to outliers. Okay,
Yes.
it is sensitive to outliers, so that's why range has it. This is the shortcoming of range. To overcome the shortcoming, what we do is we calculate a thing called IQR. IQR is interquartile range. Okay, what is a quartile?
Quarter.
Part of it.
Yeah, it's quarter like this, yes. So basically now what we do is, suppose I have, let's say, 8 values. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, I have some 8 values, okay, arranged in increasing order. So what will I do? I will divide it into 4 quarters, that is 25% each. Okay, so this is the first quarter, right? This is second, this is third, and this is fourth, right? Now what we do is, like, we remove the first quarter, we remove this quarter completely, and we remove the last quarter also, so that my outliers are removed. Okay, now this first value is called my Q1, and this last value is called my Q3. After removing 25%, the last value I got will be called Q3, and the first value after removing 25% is called Q1. Okay, and Q3 minus Q1 is called my IQR.
Himanshu,
Yes, Jashri?
this part it's not clear for me. It should be Q4, right? Why it's Q3? Because already I'm removing Q4. So.
No, is Q1 and Q3 are not quartiles exactly, it's just a terminology for this.
Okay.
Okay, So we have, you are correct, these are the 4 quarters I have. Okay, so this is Q1 because this is how we are going to start our data now. Okay, and Q2 is my median, is my Q2 now.
Okay.
Okay, so median is always after 50%, that is this and second quarter, right? So this is my median. So whenever I end up with 25%, the next value is my Q1, and the last value after removing this is my Q3.
Okay.
Okay, say for example, suppose if I have 10 values. So 10 values, the 25% is 2.5. Right? So what I will do is, let me make this 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 2.5, so I will remove the first 2 because I cannot remove 2.5. I will remove the last 2 also. Okay, this becomes my Q1, that is my third value, and this becomes my Q3. And the median is 1, 2, 3, 4, 5. Median is average of this Q2. Okay, so Q1 is called the first quartile, Q3 is called the third quartile, and Q2 is your median. Okay, so and now Q3 minus Q1 will be my IQR. Clear? That's how we calculate IQR. Now let's take an example in notes. Okay, so now the first question is, now the question here is, will the first quartile be at $25,000, left of 25 or right of $25,000? You have 1000 values. Think and answer. These are the 3 options you have. Where will the first quartile lie?
Can you repeat it?
Sure. For this histogram, yes, that is people with social networking accounts, the question is, where will the first quartile lie? Means where will Q1, what is the value of Q1 basically? Here is your $25,000, this green line. So it's asking you, is Q1 is left of this 25 or the right of it, or exactly $25,000? Okay,
It will be left of. Okay.
think and answer here.
Q1.
Okay, so I have 1000 data points. So what will be my Q1 here? I have to remove my first 250 points, right? And the last 250 points also. So the 250 first point will be my Q1, right? T251 will be my Q1. Now tell me, where will this T251 lie? Here, here, here or where?
Right of 20.
Exactly, here only 33 values are there. Here we have 155. So 251 term will be somewhere in this bar, right?
Right.
So Q1 will be the right of $25,000.
Yes.
Clear?
Yes.
Yes.
Okay, good. Now do this. So this is what is the how, IQR. Let me just show you the data completely. Can you read this out now also?
Yes.
Yeah.
Okay, so now what we have done here is this is a sample of general population, and this is a sample of people with social networking account, but you have the salary of Mark Zuckerberg also here. That is $10 million.
Mm-hmm.
Okay, I want you to find out the IQR in this case. And to give you an example, this is how we are doing it. We have 1, 2, 3, 4, 5, 6, 10 values. So we have removed the first two and the last two, right? The third
Mm-hmm.
becomes my Q1 and this becomes my Q3. So in the
Yes.
Q3 minus Q1 it becomes my IQR.
Exactly.
Okay. Similarly, now find out for this also quickly.
Mm-hmm.
Okay. Got answer from Kantesh, Ramni and Venu. Yes, Jayashri?
It's just one.
Sure. Ramni, check your answer again. I think you're doing some mistake.
Okay. Okay. Is this right?
Yes, 4944 is the correct answer.
Okay, fine.
Good. So now you can see that using this IQR, now I am saved from outliers,
Hmm.
right? So that's
Hmm.
why IQR is a good technique to find out the interquartile range, as in the spread of the data. Okay,
Mm-hmm.
great. Now do this true or false. So you have these three statements about IQR. Quickly give me answer in true or false. Yes.
Actually, there is no data. I didn't get the data.
No, there is no data. You have to just, these are just true or false.
No, I didn't get the screen that true and false.
Sorry,
I cannot see. I cannot see that true and false statements.
it is small.
No, the
Better
page
now.
is not visible.
Is
Okay.
visible?
I think when your internet speed has dropped again.
Okay.
Can you see it now?
No.
Okay. Just refresh your connection or join again or something.
Mm-hmm. I'll
I think
try.
it is stuck somewhere, yeah.
Hello.
When are you back? Okay. When are you back?
Yeah.
Can you see it now?
I'm getting it.
Okay, do it quickly then. Okay, answer please. About 50% of the data falls within the IQR. This is?
True?
It is true, yes. Why? Because we remove 25 and 25, so 50% is left,
Okay.
right? Kantesh, you say you
Yeah.
think it is false because it can be more than, yes, it can be more than 50% sometimes, but it will be very close to
Hmm.
it. So for example, in this case, we removed 40% of the data, it was 60% here, right? But usually it will
Hmm.
be close to 50% only, right? Okay, next one.
Hmm.
IQ is affected by every value in the data set. False, right? IQR is not affected by outliers, it is true.
True. True. Correct.
True.
So TFT is the answer. Great. Jayashree, is it clear?
Yeah, it's clear.
Okay. So now the question comes, what are outliers? Right? Suppose this is my data set. Okay. So what values do you think are outliers for this data set? 60,000, 80,000, 1 lakh or 200,000? Think and answer. What values do you think are outliers for this data set? Okay, Jayashri has given an answer, Kantesh has given an answer. Yes, Venu Ramni.
Yeah, I gave 4 I said.
Okay. Venu, you need to give answer from this 4 options first.
Okay.
Yes, you are correct. What you have mentioned is also an outlier.
Mm-hmm.
But I'm asking you out of these 4 options right now.
Third.
Third? But if you say third, fourth also will be an outlier, no?
Yeah. Okay, from this data.
Right.
Okay. Mm-hmm. No, fourth.
Okay, so all of you telling
Fourth and
fourth. Sorry.
Hmm.
Okay, why not third?
yeah, fourth.
Why not third?
Because it is near to 80,000. 60, 80
Yeah, 80.
and then 1 lakh will be the next data point. So it is right only.
Yeah. No, but here we have data till 60 only. Okay. No, I think you didn't got the question correctly. Okay, you are thinking out of these 4 which is an extreme value, right?
That's what you
Yeah.
asked, no?
No, it's not like
On
that.
left
Like,
hand data, right data you're asking.
what value do you think are outlier for this data set? I marked over here also. This data set.
Yeah. Okay, then it is last one. That is 1 lakh if it is. Or 10, how much is the value?
That's $10 million, but I am asking you these are the 4 options you have. So what should be your answer?
It should be 3 only, I guess.
Okay, let's see now.
I think it's 80,000.
So if you say Jayashri 80, then 1 lakh will also be an outlier and 2 lakh will also be an outlier. Because they are even more than that, right?
Hmm.
See here, okay, fine. So basically outliers are extreme values. But how much extreme? So we need to have a formal definition to calculate outliers, right?
Hmm.
So what we do is like one of the ways of calculating outlier is this. Any value which is smaller than Q1 minus 1.5 IQR is an outlier. Okay, and any value which is more than Q3 plus 1.5 IQR, it is again an outlier. Getting it? Where IQR is nothing but Q3 minus Q1. Clear? This you should always remember. This is one of the way of calculating outlier. Anything Q1 less than Q1 minus 1.5 IQR and anything more than Q3 plus 1.5 IQR. Okay? Now what I
Very
want,
clear.
sorry.
Sorry, I'm not very clear in that.
Okay, fine. Okay, what is your doubt, Ramni? Okay,
Q1 minus
1.5 into IQR and Q3 plus 1.5 into IQR. Okay, let's do one thing. I want you to calculate these two ranges, as in which is the smallest value which will be an outlier and what value will be an outlier in the upper direction. So I want you to find out this value and this value quickly for this data set written over here, this one. Okay, and it's already marked Q1, Q2 and Q3, so it will be easy for you. Do this. I will just be back in 2 minutes. Hai na? Thank you.
Renu found it.
Hello.
Yeah.
Yeah.
Right.
So what is the first answer?
4181.
No.
My
Okay.
answer was 41700.
Okay, let's check it out. What is Q1 here?
4919.
49191.
49191 minus 1.5. What is IQR?
4944.
4944, right?
4994.
Oh, sorry, sorry.
Yeah.
Okay.
So it should
Yeah,
be
4944 was
491.
41755.
Just a second. 417775 is the lowest value. Okay. And the upper bound is Q3. Q3 is 54135 plus 1.5 into 4944. Okay. It is 61551.
6155.
Right. So what does it means? It means that any value which is lesser than 41775 will be called an outlier, and any value which is more than, what was that, 61551 will also be my outlier.
Outline.
Okay. So as per this conditions, 80,000, 100,000 and 200,000 becomes my outlier. Okay. And if you see, if I have to see if mark outliers in this data set, in fact this will be also my outlier, the first one, and $100 million will also be, sorry, $10 million will also be my outlier. Clear? That's a one way of finding or identifying outliers, IQR. So Q1 minus anything less than this or anything more than this will be considered as an outlier. Okay?
Okay.
Great. Now let's discuss box plots. Okay? We'll teach you how to create a box plot when you study R. Right now we'll just explain you what is a box plot. Okay?
Okay.
So box plot is again used to measure one variable, visualize one variable only, but it is very good for visualizing outliers. Okay? Now let's see how do we draw a box plot. So we draw a box like this. Okay? Then we have something like this here and this line. Similarly, we have a line like this here and then like this. And then I have here the scale of y. Y means the variable which I am plotting. Sorry. So for in this scenario it is salary. Right? So now let's understand this. This value, the lower bottom of the box is your Q1. This is your Q3. And in between you have a median which is Q2. Okay. Now this lines, these ones are called your whiskers. Okay. And the usual length of this whisker is 1.5 IQR. So this bar becomes Q3 plus 1.5 IQR, and this will becomes Q1 minus 1.5 IQR. Okay. And if we have some outliers, we put it like this. Clear? So it helps us to identify outliers very easily. Okay. Clear?
Okay. Yeah.
Okay. Now answer me this. Does the median needs to be at the exact center of this, or it can be anything in between?
I think it should be exactly center.
Median.
Okay, how about you, Venu?
I think you asked about.
I'm asking this Q2 will be exactly in between Q1 and Q3 at the middle of the box, or it can be anywhere, here also, here also, here also.
It can be anywhere.
Oh, no, no. It should not be middle. It should be towards a little lower side.
Okay,
Upper.
Kantesh,
Because we are removing Q1, right?
In the middle, I guess.
no, it's not, see here. I have a scale over here, right? So I plotted as per the Y value. So Q1 is plotted over here, which is 25 percentile, and Q2 is plotted here, which is the median. So Q2 is not the mean of Q1 and Q3. This is wrong, right? Because Q2 is just the 50 percentile value, while Q1 and Q3 are 25 and 75 percentile values. So for example, if you see this data set, where is it? Has anyone gone offline? Okay. If you see here, what is my Q1 here? 49191, right?
Mm-hmm.
My Q3 is how much?
54135.
54135. And Q2 is the average of this two, which will be somewhere around
Yes.
51500.
Yes.
Okay. So now it won't be the exact value. It would, in this case, it would be a bit lesser than the average. So it would be like here. It is 51. How much is this? 51500.
Mm.
Okay. So Q2 would be in between Q1 and Q3, but it can be anywhere in between. It can be here also. It can be here also. It depends on the spread of your data.
Okay.
Okay. Now tell me one thing. What if we don't have any outliers? What if we don't have any outliers?
There won't be any data points.
Here?
Yes, here or down anywhere.
That's correct. There won't be any data points. Other thing is, this whisker won't extend up to 1.5 IQR. It will only extend up to the maximum value of your data set, and this will become your minimum value of your data set.
Mm-hmm.
Okay? If we don't have any outlier, we start from minimum and go up to the maximum only. We don't use this 1.5 IQR thing.
Mm-hmm.
So that's how we create a box plot.
Can
Clear?
you please briefly means explain once again?
Okay, which part? This part?
Whole thing. Just briefly that what exactly we are looking into.
Sure. Okay. So basically box plot is used to look at the distribution of your data, especially the outliers or extreme values. Okay.
Outliers
So
or
extreme values.
extreme values.
Right.
Okay.
So this is how we draw a box plot. Okay. This lower edge is Q1, this one, this level. This is your Q3, and between you have your Q2, which is your median. Okay. In case
So
of
that need not to be in the middle.
that did not, it will be in between Q1 and Q3, but it won't be as in exactly in the middle. It can be anywhere. It could be here also, it could be here also. Okay. Great. Now this whisker is usually 1.5 IQR, and your outliers are above it. Similarly, this
Then
whisker is,
outliers are above it. If it is not there, then
sorry, if outliers are not there. If outliers are not there, then I won't go up to 1.5 IQR. I will only go up to
Minimum,
the
maximum.
maximum value of the data point.
it will be less than 1.5.
Sorry? If it is more, it will be shown as an outlier, no? Then
Okay.
if it is not, then you have to put it as the maximum. Get it?
Got it. Yeah.
That
Okay.
means there is no usage of whiskers if there is no outliners.
Exactly. It's like it would just show you the
Right?
maximum and the minimum value. Yes.
Yeah.
Okay.
So means if you don't have an outlier, then box plot won't make a lot of sense because you cannot find the extreme points. Since there are not any extreme points, so it won't show you that. Okay, but we use it just to see whether we have outliers or not. Just by plotting it, it's very easy for us to see whether if the data has outliers or not.
So
Clear?
once we plot this graph only, we'll understand whether there are any outliers or not.
Exactly.
Extreme
Yes.
points and all.
Exactly. Yes.
Okay.
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 Great. Now the question here is, I have drawn 3 box plot over here, 2 for the social networking account. Out of this 2, sorry, that you have to identify, just a second. That you have to identify, okay? So 2 with the social networking account and 1 for the general population. Okay? In social networking account, we have taken 2 cases, one with Zuckerberg's salary, that was $10 million, and other one is without Zuckerberg's salary. And this one is for general population. So now you have to match these blanks with A, B or C. Okay? And just to give you a hint, don't ignore this point. You have a point over here. Do it now. Done? Not getting any good answers. Okay, Kantesh, better than before. Ramni, you answer?
I gave.
No, that's not correct. Think again. Jashri, you give, you're giving in order of the blanks?
Yeah.
So where's the third one? Okay, so third I should assume as A only?
Yes.
Okay, how would you, Venu?
No,
I'm not
actually,
able to.
sorry.
This,
I'm just giving again.
okay, yes, Venu?
I'm not able to do it.
Okay, fine. But you understood box plot?
Yeah, I understood that.
Mm-hmm.
But what is the exact question? I'm not.
Okay, so basically we have drawn three box plots here. One is for this data, general population. One is for people with social networking account, including the salary of Zuckerberg, that was $10 million. Another one is for again for the same social networking account people, but without Zuckerberg's salary.
Okay.
Okay, so you have to match key which box plot is for which condition.
Okay.
Got it? Give it a try, then we'll discuss quickly. It's not that difficult, it's easy.
I have given the new answer.
Very good, Yashri. Kantesh, I got only one answer for you from you. What about rest two? Okay, good. Kantesh also got it now. Ramni, think again.
A and C are for social networking and B is for this.
Okay, let's discuss it now. Okay, let's see. Yeah, general population is B. I think all of you given it correctly. Why B? Because it is more spread out.
Okay.
Right? Now comes A and C.
Right.
In C you can see an outlier like this. So C is with Zuckerberg.
With?
Zuckerberg. That's why we an outlier here, na?
Right.
And A is
Dot.
A
Okay.
is without Zuckerberg.
Okay.
Okay.
Got it, Venu?
Yeah.
So it's C, A and B. Why general population is B not A? Because general population is more spread out. So there should be more gap between Q1 and Q3. Clear? So you can draw the box plot horizontally also is one and the same thing. It doesn't make any difference. You can rotate it also and draw it in horizontal way. Okay?
Yeah.
Great. Now let's move ahead. Okay, now this is a very good question. Will the mean always be between Q1 and Q3? Think and answer in your chat boxes. Will the mean always be between Q1 and Q3? Okay, got an answer from Ramni. Very good. Yes, quickly others also.
Asking about mean.
Exactly. Will the mean always be between Q1 and Q3? Okay. Venu and Ramni say no. Yashri and Kantish says yes. Okay, Jayashree, explain.
Because you are having the average obviously it will take the
Okay, just tell me one thing, Jayashree. If I take Zuckerberg's salary in picture,
Mhm.
what will be the mean?
Okay.
It would be very high, right?
Yes, it will be very high.
So it's not necessary that mean should come here. It can go out here also. It can come here also,
Yes. Yes. Yeah.
depending on the outliers we have. That's why we
Okay. Okay.
say whenever
If we
we
have
have,
outliers, then it
yes, that's why we say whenever we have skewed distributions, better go for a
will. Mhm.
median.
Yes.
So the answer is no here.
Mhm.
Got it,
Mhm.
Kantesh?
Yeah, got it.
Good.
But if you don't have outliers, then it will be in between Q1 and Q3, right?
Right, that's why I ask you always.
Okay,
Yes.
okay.
It's
Yeah,
not
yeah, got
always,
it.
you know. Okay, good.
Okay. Okay.
Okay, great. Now let's move ahead quickly. Now we have seen two ways of calculating spread. One was range and other one was IQR,
Mhm.
right? But IQR has also one a problem that IQR is only considering two values Q1 and Q3 to calculate the
Mhm.
range,
Mhm.
right? Now what I want is I want some method which takes all the values to find out my spread.
Mhm.
So if I have x1 to xn, I want a method which includes all these values to find out my spread. Okay? Now what it should be? Let's this where is it gone? Yeah, chalo. Okay. Now these are the suppose these are my 6 points 1, 2, 3, 4, 5, 6, and I have to measure variability for the 6 points using all the values. Okay. These are your three options for measuring variability using all data values. Out of these three data points, what do you think should be a better way of measuring variability?
ఏ
Quickly.
మొత్తం స్ప్రెడ్ అయిపోతాయి. సారీ. హలో,
Yeah.
వాట్ వాజ్ యువర్ క్వశ్చన్?
The question is I want to devise a method to find out variability which involves all the data points I have. You have these three options. What do you think should be a suitable way of finding the variability? Okay, Ramne has given answer, Venu has given an answer. Okay, good. Jashi, okay, fine. Kantesh waiting for your answer. Jashri, you say
Please explain, I
one.
can't get it.
Okay, you got the question?
Yes,
Yeah,
it's
Okay, so
yeah.
I need to devise a method to find out variability between
Mhm.
which uses all the points, right?
Mhm.
Suppose I have these six data points 1, 2, 3, 4, 5 and 6. Okay,
Mhm. Mhm.
now the first option says find the average distance between any two values. Means
Oh,
find
sorry.
the
Yes. Any two. No.
distance between any
Okay.
two values, like this one, this one,
Hmm.
this one, this one, this one. There's only one set, then this,
Hmm.
this, 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 and many more. So means find out the distance between any two values and then take the average. Okay, that's the first suggestion.
Hmm.
Okay, so suppose I have 6 points. How many distance should I measure? I have to measure in this case. If I do it like this, if I have 6 points, how many data points I will be measuring? How many distances I will be measuring? Sorry.
No,
What the question?
should not be. Hmm.
Yes, Jashri.
No, it should not be the option actually.
Okay, no. Just tell me how many distances I am going to measure here. It should be, if
Okay.
you're comfortable
Factorial.
with, sorry.
6 factorial.
No, not 6 factorial. It will be
More than
62. 62.
hmm.
Okay.
I think few of you might have not been familiar with this. It's okay. It's nothing but 6 factorial upon 2 factorial into 4 factorial, which is nothing but 6 into 5 upon 2, which is 15. So I have to measure 15 distances. A better way to find out is like this. I have 6 points A, B, C, D, E, F. Okay. So I have to measure AB, AC, AD, AE, AF, right?
Hmm.
BC, BD, BE, BF, CD, CE, CF. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have skipped some.
BC then
EF, EF. You have skipped EF.
Right, EF, yes, sorry.
yeah. Hmm.
Okay, now I have to calculate 15 distances and then take the average. Right? It's a decent method, but the problem is it is computationally very expensive.
Yes.
If I have 100 points, it will really go huge, which is 100 C2, which is 5050. So I have to measure these many distances.
Yes.
So okay, instead, so first option is not very promising. How about the second one? Find the average distance between each data value and either the maximum or minimum. So what it is telling you in this case is, I have 6 values. Okay, first fix, let's say I'm measuring everything from minimum. So measure this distance, this, 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 and this. Sorry. Okay, so this time you have to measure only 5 distances and take the average.
Yes.
Right? But the problem in this scenario is, in the final average, the contribution of this value will be the most. Right? Which is actually my,
Yes.
which can be my outlier, right? Because it is the extreme value. Okay, so this method is prone to outliers. If I outliers, then the average also will become very high. Now the third option. Third option says find the average distance between each data value and the mean. So what it says is, I have the 6 data points. Let's say my mean is here. Okay. Now I have to find distance everything from the mean. Okay. So now what will happen here is, if you have an outlier on the positive side, this will be high, but it could be cancelled by outlier on the negative side also. Okay, and the number of distances will be 1, 2, 3, 4, 5, 6 only. Sorry, 5. Yes, 6 only. Okay, so this is a very what you call, this is a good way of finding variability. That is, find the average distance of each point from the mean. Okay, so we are going to start with this and let's see how we will be implementing it. Okay, great. So now let's do this. So I want you to quickly write down these points in your Excel sheets very quickly. Let me know once you're done. Sorry. Yeah.
Done.
Okay. Just ping me the values. If you're done, find out the mean for this.
Yes, means
Sorry. What is the mean if you have done with the data? Hello?
Yeah,
it's
it's
5279.
52793.
52793.8.
Okay, just give me a moment. It's
You
not
are
reading.
not adding the last one.
No, I'm adding it, taking it as a text. I'm just converting into
Yeah, value
number.
na. Special paste.
Okay, sorry.
Right click.
You can do Alt ESV after copying.
Sorry, alt.
After copying, you can do Alt
Mm-hmm.
ESV.
Special paste.
ESV.
Select value.
Yeah, just one by one you need to click Alt ESV.
S and V.
Text.
Yeah.
You can T. Here it yeah, text.
So it would paste as text only. No, I don't want that.
Yes.
Yeah, okay, now it's
right.
okay. Now it's okay. Okay. Okay, great. So now the average is 52793.8, right?
Yes.
Okay. Now what I have to do is, let me write it over here. Average of these points. Okay. Now this is my
Yes.
x. Now what I have to do, I have to find the distance of x from x bar, that is x minus x bar. Okay. So what I have to do is I have to subtract each and every value with from this value,
Mm-hmm.
right? When you look at this carefully, so what I will do is I will put is equal to this minus this. Okay. Similarly, you have to do for each and every value, but shortcut is you can drag it like this. Okay. But if you drag it, let's see what will happen. It won't give you any difference. Why? Because if you see the formula here, it is K22 minus L19. This is my L19. But if I drag it, it becomes L20 now, which is empty. Right? So in Excel, what you have to do is we have to freeze this cell, L19. So what I do is I have to put a dollar sign over here, like this. $2 like this. Okay? So dollar signs means don't move L19, only move K22. Now if I drag, I will get the correct answers. When are you getting this?
Didn't
Sir?
you put $1 only, no? Oh, $2.
One will also do here, but you need to put only with
Or else
19,
you can
19 value.
F4 also.
Yeah, I have used F4 only. F4 is a shortcut for this. Just press F4. F4 will automatically give you $2. If you press it one more time, it will give you $1 and then again $1.
K22. What you're doing, mine?
Sorry.
No, I'm not getting the double.
Okay.
Can you show it again? I skipped that part.
Sure. See here. I'll just remove it and show you again. Let me remove this completely.
Okay.
See this. I have to subtract each and every value with 52793.8. One way is just as simple as this. Use this minus type the value. If you're facing any difficulty, just put it like this and then drag it. You will get correct answers. But you should know Excel also. So what I suggest you is you have to select this first minus this value. But now you don't, if you drag it, the cell also moves. You don't want to move L19. So when your cursor is blinking on 19, just press F4. It will bring $2 signs. So now it will freeze L19. Now drag it again. And look at the values for each column. So it is K23 minus L19, K24 minus L19, K25 and so on. Right?
Yes.
So to freeze a particular cell, we use this dollar sign concept. Or otherwise, if you find it difficult, this is the best way. Just write the value for the mean. It won't take much time. Venu got it?
Yeah.
Both the ways? Sorry?
Yeah, got it.
Okay, now let's, how about you Kantesh and Jayashri, got it?
Yes.
Okay.
Yes.
Now we have calculated deviation from mean also, and this should be the values. Just match whether you're getting these values or not.
Yes.
Yes?
Yes.
Yeah.
Okay. Now find the average of this deviation. Find the average of this deviation.
Ibala.
0.
into
0.
Is it 0? Jayashri?
Yeah.
Okay, Venu?
Average deviation.
Yes, average of the deviation that you have calculated. Average of these values. Sorry.
it's minus 2.91.
No. It should be 0 only. Let me show you this. Select this. And it is minus 2.91 to 10 is to the power minus 12. This means exponent minus 12, 10 is to the power minus 12, which is nothing but
Okay,
almost
okay.
0.
Yeah, right.
It's a very, very small value.
Okay, exponential is more.
Clear?
Yeah.
So now why I'm getting it as 0? I wanted to calculate the variability, that's why I calculate the deviation from the mean, and then I average it. So getting 0, so it's not giving me the variability correctly. Right? So I need to do something for this. Okay, first answer me this. What is the equation for average deviation that we have calculated right now? How can I write it in the terms of an equation? These are your 4 options, 1, 2, 3 and 4. Only on the chat box, please. Yeah. Okay, Venu. Good. So correct answer is the last one only.
Last one.
What we have done is we have first calculated xi minus x bar, which is these values, and then taken the summation, that is added them up and then divided by 10, right? So which is this fourth option only, which is 0. Well, if you're not comfortable with summation and also sign, no need to worry about it. It's just an extra question. Okay. Now the problem here we are facing is, since my mean is usually in the mean is here, the left ones are giving negative values and the right ones are giving positive values, right? And now if I am adding it, I am getting a 0. And this will be always for any data set. If you calculate the average deviation from the mean, it will be 0. Okay. Now how can I save myself from this issue? Because I know that there is a variability in the data. The data is spreaded. How can I calculate it? So now the question is, how can we prevent the negative and positive deviations from cancelling each other out? These are your 4 options. Ignore negative, multiply each deviation by 2, Square each deviation, there is nothing we can do. Quickly answer only on chat box. There is more than one correct, by the way. Venu? Okay, great. Now let's discuss this. Ramni, you said second one, multiply
Yes.
each division by 2. Jayashree also said second would be correct, but why is second correct? Multiplying by 2 won't make any difference. The negative will be twice.
No. Actually, it should be square each deviation.
Exactly. Third is correct, square each deviation. But there is one more option correct.
Ignore negative sign.
Right. Ignore the negative sign. We can take the absolute values. Right. Modulus. Absolute values only. Okay. Now let's do it.
Yes.
Now in Excel we have a function called ABS. Okay. Which will ignore the negative sign, only giving the positive, only give me the number part, remove the signs. ABS and select this data and press enter. And now just simply drag
ABS.
it. ABS, yes. ABS stands for absolute value, that is ignore the negative signs.
Yes.
So now if you see, you will get all the positive values, but the value would be same, only the sign would have been removed. Right?
Yes.
Okay, great. Now what is the average absolute deviation? Calculate the average of this quickly.
13543.56.
Good. It is 1354. Sorry. 13543.56. Yes. 13543.56. Let me also do it over here.
Right.
Oops, sorry. AVER, a tab, then these values and bracket 1, that's it. 13543.56 is the average absolute deviation, right? So this is one more measure of variability, absolute average deviation. Okay, but we don't use it much frequently, we use another way. Now what we do is, okay, I'm ignoring this question, it's just the formula. Now let's do the second way, let's square these deviations. Okay, I am going to square each of these deviations. So how do we square it in Excel? We select the value, we put this cap sign which is shift 6 and then 2. Now just drag it. Okay. And then take the average of this. It's a pretty huge value because the data points were in thousands of dollars. Now we also squared it, so it's become
Yes.
much more bigger. Okay, clear in here? Venu, Kantesh?
Yes, clear.
Okay. So the average square deviation, how much the value we have got is called variance. So what we have done here is we have calculated summation of xi minus x bar whole square, right? This is called sum of squares, and then we have divided it by 10 or the number of values, let's say n. Okay, this is the formula of what you call variance. Okay, heard about this variance term? Okay, so variance is again another measure of variability. But the problem is with variance is that the unit of variance is not same as the unit of your data points. It is in fact the square of it. So my data points were in dollars, now the variance will be in dollar square, right? So it's in a complete different dimension. Okay, but still it is very much applicable in day-to-day problems. Okay, so this is, you should write this variance and you should also write the formula for this. Now tell me this, how can you put variance in words? These are your three options very quickly. There are two options correct. Okay, let's discuss. It is mean of square deviation. Yes, that is true. Why? Because we have summation of xi minus x bar whole square upon n. So it is mean of the square deviation, right? Sum of square division divided by n. Yes, one and the same thing. Sum of square division divided by n. Third one is mean square division squared. Means it is squaring this again. This is wrong.
Okay.
So the correct options are only 1 and 2.
1 and 2.
Got it?
Yeah.
Okay. So now let's bring variance again to one dimensional data. Since we have square of the data, let's see how we can bring into one dimension. Now what we are doing here is, these were my 6 points that we talked about, right? This was the mean. So first of all we calculated xi minus x bar for each point. So for say this, for this point, this was my deviation, xi minus x bar, right? Now if I square it, what I am getting is the area of this square, which is a square, right? Similarly, I am adding areas of all such squares and then averaging it. So what I am getting is graphically is the average square area of this square. Okay, but my data was in dollars, this is in dollar square, so I want something in dollars again. So how can I convert some number in dollar square to dollar again? These are your
Square root.
options. Exactly. How do we convert the dimensions of average square back to one dimension, dollar, from dollar square?
Take the square root.
Exactly, we will be taking the square root.
Square.
So now what I'm going to do is I am going to simply take the square root of it.
Mhm.
Okay, and this thing is called your standard deviation, and which is the most used measure of variability. It is represented by sigma. Okay, I should add it over here. Greek letter sigma. Sigma is equal to this, and this is called your standard deviation.
Himanshu, can I please repeat this part?
Sorry?
Can you please repeat this part once again? Standard deviation.
Okay, you want me to repeat this? Sure. What I am doing is I have just taken the square root of this, of my variance,
Oh, very.
so that again dollar square should come to dollar. Okay, and that's it. I am calling it standard deviation. That's it. This standard deviation is represented by sigma. Venu, getting this?
Yeah.
Sure?
Mhm.
Great. So now we started with range, we studied IQR, we studied absolute average deviation, then we studied variance, and then we studied standard deviation. Right? We also studied outliers in between, that's okay, but these were the measures of my variability. And HD is the most used in the, what do you say, in your common day-to-day problems.
Yes.
Okay?
Hmm.
Great. So now quickly find out the value of sigma from your data. Find out this is the variance, right? I want the standard deviation, so just take the square root of it. For square root there is a function called sqrt, sqrt, and then just select the point value and just press enter. Okay, what is the answer?
Is it 5400.2?
No.
So we'll find variance.
Variance you've already found na here.
Fine.
Just take the square root.
The square root of that variance, right?
Exactly.
I'm getting 5400.2.
No, check your variance first.
17076.
Right.
Yeah, 17076.
Good, Kantesh. How about you, Venu?
Yeah, actually I'm very slow in Excel, so I have to try very hard and I'll practice it afterwards.
No, that's okay, but I want you to do in class also, है ना? Means
Yeah,
don't take Excel as a very big issue. Excel is a very easy thing to learn. It's just a matter of few
yeah,
days.
but because actually I'm not in touch with Excel for many years, that's why.
Okay, no issues. So have you done the variance till variance part?
Yeah, I have done that.
Okay. So just take the square root, that is equal to SQRT and this value.
Mhm. Okay.
Venu, I would say start learning Excel also because it would come very handy.
Mhm. Yeah, like from Monday I'll start. First I'll go with Excel and then I'll see all the assignments afterwards.
Okay.
Can you, it's coming same only 54001.
Ramni, can you just check your value of variance also here?
Your variance is same.
So how come the square root is different?
Okay. 1 second.
Ab
I
n se,
divided it by 10.
no, we already divided in the variance only, no? Variance is already the average.
Hmm.
Okay, just take the square root now.
Okay. Fine.
Got it?
Hmm.
Good.
Got it.
Now let's move ahead.
Ah, okay.
Okay. Let's see how we can find out the same thing in using spreadsheet. Okay.
Hmm.
So rather than using this data, I will be using the data that we have already. This one. Okay. So now we know the standard deviation is 17,076. Right?
But do we get such a huge standard deviation?
It depends on the data you have. Your data is also in thousands of dollars.
Okay, okay, fine.
Okay.
Because actually we don't calculate, means I do in SAS now, we get very small numbers in standard deviation.
So no, Ramni, it all depends on your data set. How big is that? How big values you have?
Okay, 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 fine.
Okay. Yeah. Now let's do one thing. In Excel we have directly a formula to calculate standard deviation.
Okay.
So instead of doing all this thing, we can straight away use STDEV followed by, if it will give you all this example, put a P. P stands for population. I will explain you why I am using this, and then brackets, and select the data you have, and just close the bracket and press enter. Why am I getting 0? Oh sorry, it's not, it's text data. Let me use it over here. STDEVP,
Yeah,
and then
directly we are getting.
yes, these values, yes. Okay, you will get the same
Yeah.
value.
Yes.
Venu, got it?
I'm trying.
STDEVP is the function. Kantesh?
Yeah, got it.
Okay. So from now onwards, I'm not going to do it by this bigger way. I'm just going to do it by this way only.
Fine.
Clear?
Yes.
Good. So this you can do as a homework. So this question you can do as a homework, you know. Just put this in spreadsheet and use HTTVP. Okay. Now tell me this. What is a way to put the standard deviation into words quickly?
2 words.
Uh, put your answers in the chat box very quickly. Multiple answers. Jayashree, your one option is wrong. Yes, Venu? Okay, good, Venu. The correct answers are the first one, square root of average square deviation, and fifth one, square root of sum of square deviation divided by n. Is nothing but average only. Ramani, you mark third is sum of square division. This is not standard deviation. It is only this,
Okay.
right?
Yeah.
And some Jayashree you marked second. Second is average square division again squared.
Mm-hmm.
It's variance square.
Yes.
That's again wrong, right? So first and fifth are the correct answers.
Yes.
Great. Okay. This is again a homework for you. This is the data set for which you have to calculate the standard deviation. So you can use STDEVP. Please remember this formula, it's very handy. STDEVP to calculate standard deviation. Okay? And this is again your homework.
Okay.
Okay? Great. Now let's discuss this important stuff here. What is so great about standard deviations? Standard deviation is something which you have to use if you get into data science on an almost daily basis.
Mm-hmm.
Okay.
So why is it so important? What makes standard deviation as the best choice of variability, and why do we use it again and again? So the answer to this is, suppose I have a normal distribution.
Mm-hmm.
Okay. Now suppose this is my mean and sigma is my standard deviation. Suppose if I go to the right of mu by a distance of sigma. So this is mu plus sigma now, right? Now if I move here, again a distance sigma, it is mu minus sigma, right?
Mm-hmm.
So for a normal distribution, the area, this area is the area of the relative frequencies, or you can say the proportion of your total numbers. This area is always 68% if it is normal distribution. Okay, this we are going to verify in the later chapters. And suppose if I go 2 sigma away from the mean, mu minus 2 sigma, 2 mu plus 2 sigma, right? This is my mu. This area now is 95%. Okay? So now what is the meaning of 95%? It means suppose if I have 100 data points, whatever be the points, 95 of the points will lie between mu minus 2 sigma to mu plus 2 sigma. This is always true. Means out of 100 point, if I have 100 data points, 95 points will always be your in this region only if you have a normally distributed data. Okay, that makes the application of standard deviation huge. Getting it, Venu?
It's not clear for me.
Yeah, what's the doubt, Jashri?
Yeah, not clear actually.
Okay, so what I was telling you is, suppose you have, if you move 2 sigma from the mean,
Mm-hmm.
okay, this area is always 95%.
Okay.
That is 95% of the total data points will always lie between mu minus 2 sigma to mu plus 2 sigma.
Okay. Mm-hmm.
Okay, let's verify it. So if you have confusion, I'll just verify this for you. Let me open this data sheet. Yeah. So this is the data, salary data of people with social networking account, and I have 100 observations. Okay. Then I found my mean by X bar, that is mu, which is by average formula, which came out to be $50,500. Right? This you can do.
Okay.
Then I calculated my sigma, that is standard deviation, using STDVP, which came out to be $10,656. Okay. Then I calculated X bar minus sigma and X bar plus sigma. X bar minus sigma is 50,000 minus 10,000, that is 40,000, and 50 plus 10, that is 60,000. Okay. Now what you have to do is you have to count how many values are between these two values.
Okay.
Getting it, Venu? So now let's start looking at 39929. So this value is below, before it. We'll start from here, 40283.
Yes.
Right? Then I have to move to 61243. Up to here.
Yes.
Okay. Now if I count these values, if you see the count here, let me put it to count. You can see 69. Okay. And the theoretical is 68. So it's pretty close to it. Right? That is 69 data points are always between X bar minus sigma and X bar plus sigma, or mu minus sigma or mu plus sigma. Now let's do it for 2 sigma also. X bar minus 2 sigma and X bar plus 2 sigma. Okay. So X bar is this minus, sorry, where is minus 2 into sigma will give me this value, and X bar plus 2 into sigma will give me this value. Okay. Now let's count the values in between this. I have to start from 29272 till 71900. Where is 29272? This is smaller from here.
7th row. Yeah.
Right? And then I have to go till 71900, which is up to here.
100.
Okay. Now if I start counting this, it is how much? It is 94 values.
94.
Right? And the theoretical says it should be close to 95. Okay. So that's what is makes sigma important, that it gives you a what you call graphical way, or if give you a sense of the variability you have. Right? Because variance and they cannot give you, they're not giving you any sense. Sigma gives you a sense of the variability you have in your data. So now I know that within 2 sigma my almost all the data will be covered. Right? And within 1 sigma it is 69%. So this is applicable in a lot of areas. Have you heard about 6 sigma and all?
Yes.
Yeah.
So 6 sigma comes from here only. Okay, 6 sigma is...
Okay, are you calculating the sigma and getting the percentage?
Yes.
Okay.
I am just trying to verify these values, 68 and 95.
No, how did you say that it will be fit into 2 sigma, right?
Sorry, come again, Amni.
I didn't get that point. You said the whole data will be fitting into 2 sigma.
Not whole data, 95% of the data almost.
Okay, 95%.
Right.
So, how did you give this definition? I didn't understand.
This 68 and 95?
No, 2 sigma
Uh-huh.
is common for all the graphs, or is it that you are calculating that your data will be between these 2 sigma?
See, For any data point you can find your X bar and 2 sigma,
Okay.
right?
So can you give me a brief explanation about 2 sigma?
Means I didn't get brief. What do you mean? I didn't get your question. 2 sigma is nothing but 2 multiplied by standard deviation.
Oh, okay, fine, got it now.
Okay, and sigma is has to be calculated from your data only.
Hmm.
So what I want to say you here is, if your data is normally distributed or close to normal, which happens almost, which happens in most of the cases in your day-to-day data. Let's say, Venu, let's just say your salary data in any company, it is normally distributed. So maximum people are in within, only few are have a very high salary, and only few have a very low salary. Most of them are in the between only. Right? So normal distribution has a variety of applications. Anything you do would most probably in a spread fit in a normal distribution only. Okay.
So my question still not answered, Himanshu, because I think I'm not clear in asking you.
Okay.
See, if you have any other data, they will be only 2 sigma, or it may extend. Means it will go to 3 or 4.
No, see, it will go after that also, na. See, 2 sigma is only 95%. 5% is still left. It will be here and
Okay,
here.
okay.
See, what I am
Okay,
telling you,
got it.
Ramne, is 95% will be covered into this, 5% will be beyond this. And that is only true for normal distribution, not for a skewed one.
Okay, fine.
Okay, this will be only true when, say, normal distribution is there. Got it?
Sure. Got it.
Okay, great. Can you just bear with me for 5 more minutes? Let me finish this chapter.
Yeah.
Okay, thank you. So now I'm just going to explain you why did we use this STDVP. Okay, and one more thing I'm going to discuss is Bessel's correction. Okay. Okay, so okay, I will leave it here. I'm not taking this. Okay, let's do it in the next class because I want you to remember these things. Okay, and it won't matter much in your assignments also. So I will start from here from the next class, this part. Okay, and then we'll move towards lesson 5 and lesson 6. Now I've already sent you the notes and assignments of lesson 1 to 4.
Yeah.
So please go through them, do the assignments. We are definitely going to discuss on them next Saturday without any excuses. So please do them. Okay?
Yeah.
We know.
Assignments, we need to send you the answers.
No, you don't have to send me the answer. I will discuss the assignments in the next class. At that time I will tell you the answer. You have to check it. If you have any doubt, you can ask me.
Okay, fine.
Yeah, Venu, you're telling something?
No, nothing.
I hope you can see each assignment won't take more than 2 hours.
Yes, you're right.
It's pretty easy and it won't take more than 2 hours. If you start doing it, it will be, it's a good practice to do the assignment continuously. You will remember all the things.
Okay.
Okay? And in case of any doubt in concern, you can WhatsApp me anytime midweek also. That's not the issue. Okay, so stay connected and please start studying and solving the assignments. Okay, one more thing.
Himanshu,
Yes, Ramni?
WhatsApp number?
Sorry?
WhatsApp number.
Okay, I will ping you right now in the chat box.
Okay.
It's 8108094992.
Okay.
So you can call me also on this number and WhatsApp also, anything you can do.
And there is particular timings to call you?
See, if I'm in a class, I won't pick it up. Otherwise, it's okay. I'll give you a call back in case I'm busy somewhere. Okay.
Okay.
You can call me. See, you can call me anytime from 11 to 7.
Morning 11 to 7. Okay.
Right. Because I have classes after 7 on weekdays. Okay.
Okay then.
Okay. One more thing I
Thank you
wanted
very
to.
much.
Thank you. One more thing I wanted to ask. Is 3 o'clock okay with you or 3:30 is better?
No, 3 o'clock.
3 o'clock is okay.
3:30 won't
Yeah,
suit
3
you?
o'clock
Otherwise,
is
if you
okay.
start early also, it's fine.
No, I have class at
Yeah,
10
it's
No,
to.
okay.
actually,
Yeah, go ahead.
yeah. Actually, it takes 5-10 minutes to get adjusted to that microphones and earphones and settings and all. So
Right.
3 is okay.
Okay, fine. Okay, so 3 p.m. next weekend also.
Okay.
Okay, thank you so much. See you next weekend.
Yeah,
Thanks.
thanks.
Thank you, Himanshu.
Yes, Jayashree, yes.
Thank you. Himanshu, you have any morning batch also?
We have a weekday batch. That
No,
is,
Saturday morning batch.
yeah, we have 10 to 2. But that's
Okay.
not parallel with you. It's one is before you, 2 weeks before you.
Oh, okay, fine.
Okay.
Apart from this, you have any other courses also?
No, we do only data science only.
Okay, fine.
So we do statistics R and Tableau.
Yeah.
Okay, chalo then, thank you so much.
Thank you.
Okay, bye.
Thank you.
Bye. Bye,
Thank
all of
you.
you.
Bye. Bye Kantesh, Jayashree, Ramni.
Bye.